as far as you can get. It'll take about 5 or 10 minutes to do this. I would recommend you draw the ray diagrams first, just so you can get a practical idea of how to practice. First, I draw this ray that goes through F. And then I draw this ray that comes down here and comes back down at the same angle. Well, clearly, on this side, the rays never converge. But there are virtual rays that go that way and go that way to make that candle over here. That's what it should look like. So a lot of times you might not be able to converge these, and if it's clear if they don't converge, you got to take another step and draw them through the mirror to look at the virtual rays. And then now you can clearly see where this negative comes from. So what's my magnification? It's
the ratio of
I over P, right?
yeah.
So in this case, what's this going to be? It's going to be I is minus 3.3. Oh, sorry, it's minus I over P. So there's a negative there. It's a negative there. It cancels out to make it positive. And then this is 2, right? 1 point, what is that, like 1.7 or something like that? I'm just going to
Probably 1.67.
1 point, let's just call it just rounded, right? Something like that. So you get an image that's bigger. That makes sense. You get an image that's upright. That makes sense. Right? So if you got a positive magnification, you got an upright image. If you got a negative magnification, you got a inverted image. And so if you were to actually look at an image, not only would it invert, vertically, it would also mirror in sideways, horizontally as well. So everything would be flipped in all directions. Okay, let's do a convex mirror. How do these work? These are a little trickier too, right? Because for a convex mirror, you have a focal point that's negative. That means the focal point is on the other side of the mirror, right? Here's our primary axis. Convex mirror. It says here that its focal point is minus 10. So that's 5, 10. Here's F. Great. And we want to determine the height and the image for these same distances. Here's an image that's at 35. So there's 5, 10, 15, 20, 25, 30, 35, right? Here's my image, and it says it's, once again, 2 centimeters. I don't know why it makes it so tiny, but there it is. 2 centimeters in size. And we want to draw the ray diagram. So we follow our directions once again. The first one is perfectly parallel. And what happens? It should go outwards, right? A convex mirror will make things go away from the center, whereas a concave mirror focuses rays inwards. So how do we know which way it goes? We draw this. Virtually, it's going to go through the focus, and then we know that the reflected ray has to go out that way as a result. These two lines are supposed to be the same line. Let's make that a little more accurate. This line should be a continuation of that one, like that. That looks a little bit better. Rough. And then what's my other one? I draw to, sorry about that, once again, very shallow angle. And it comes back out at the same shallow angle, right? Well, where does that end up being in terms of the virtual ray? It's this very shallow angle like this. And so here's my image.
Something like that.
Pretty small, right? Whatever it is. So that's my image over here. And is it virtual? Yes, it is, right? Because it's negative. It's on the inside, on the other side of that mirror. So we can't go there and touch it and mess around with it. It's only because if someone was over there to look at it, then they'd see that image. Just like any other mirror. So we got 1 over 35 centimeters for P, plus 1 over I is equal to 1 over minus 10 centimeters. Right? So that's a negative number. So I is 1 over minus 1 over 10 centimeters minus 1 over 35 centimeters, right? What's that number? Let's check. We got 35 inverse negative 35 inverse minus 10 inverse, and then I take the inverse of that, and I get 7.8. Is that right? Negative 7.8? Right, so this is 7.8. I don't, on the diagram, I don't put the minuses and pluses, I just draw this distances in the diagram, right? But that's what that should be, and you know, it wasn't perfect, but it's somewhere between 5 and 10. So I feel pretty good about that. Why don't you guys do the same thing for B and C? Take about 5 or 10 minutes to do that. And see if people are ready, we'll look at it. And then, what else do I got? I got this, right? And then it reflects back, and here's my image, right there at 5. So that should make sense with our calculations. What about 5 centimeters? Let's move this in. Here's F, once again, at 10, and then I go half that distance, so here's, maybe a little bit further. That's my candle's getting brighter and brighter, getting bigger and bigger. There's my candle. We should probably make it more like 2 centimeters the way it asks for. So there's more like 2 centimeters, and so we go great. There's that. There's that. Right, parallel rays that go through F. And then this one over here. Something like, oh, that's probably not so good. Probably something like that, right? What does that look like? Let's go with 5. And so this will be -5. And who's got that one for me? 1 over 10 minus 1 over 10.
Negative 3.23.
3.23. Right, so it's actually somewhere like, I guess I didn't draw that quite right. It should really be like right over there, right? That's really what it looks like. Sorry about that. Make it sloppy. That. Alright, let's take a 10-minute break and we'll come back and